Have you ever had to decide between going out or staying home or picking out what to eat? Our lives are full of decisions, and similarly, so are programs. In C++, branching is the way we allow our code to make choices. It's how we respond to input, adapt to conditions, and decide what happens next. Without branching, programs would always be linear, the same thing every time. But with branching, they become intelligent. Imagine you're walking and you run into a sign that says, if it's raining, take an umbrella. Otherwise, enjoy the sun. That's an if-else statement. In the example code we have here, we start by defining a temperature. In this case, we define 68 degrees. Now, we employ an if-else statement to make a decision. If the temperature is greater than 75, it prints it's warm out. Otherwise, which is the case here, it prints might need a jacket. This is branching in action. The code is checking a condition and reacting based on whether or not it's true or false. You can think of it like a fork in the road. Does the temperature pass the test? If yes, go left. If not, go the other way. So, while we're out here with umbrellas and rain boots, the code is doing the same kind of thinking. And that's how branching logic works. Here, we can see a student standing at a vending machine, deciding what to drink. She types in a number, and depending on what she enters, the machine gives her something different. That's exactly what the code on this slide is doing as well. In our code, we see that she has a choice of 3. Then, we check that value through a series of if, else if, and else conditions. If she entered 1, the program gives her water. If she enters 2, she gets a soda. And if she enters 3, which she did, she gets juice. If she were to type in anything else, the machine would respond with invalid selection. Each condition is tested in order, and as soon as one is true, that's the path the program takes. It does not check the rest. This means else-if statements are perfect for when you have multiple options, but only one of them should actually run. So, in this case, just like real life, the vending machine has to be clear about what options are available and make sure to give a message if the input doesn't match any of them. Now, imagine you're sitting in front of this old school TV setup with an old game on the screen. You're able to choose from a list of options: play game, load game, or exit. In the code here, we're simulating that using a switch statement, in which we chose option 2. The switch then compares that value against a list of possible cases, where case 1 is play the game, case 2 is load the game, which is the one that'll run in this case, and case 3, which is exit. Each case includes a break statement that stops the code from falling through into the next case. It's a very important feature of switch statements. If you forget break, your program might execute multiple cases back to back. Then, we also have the default case. It's sort of like a safety net. If the user enters something invalid, the program will print unknown option. This style of branching is very clean and very efficient when you check the value of a single variable against a known set of constants. It's faster and it's more easily read than a long chain of else-ifs, especially in things like menus, selectors, or like key-based commands. Now, imagine you're trying to get into a concert. The music is loud, the lights are flashing, and there's a long line at the door. There's a bouncer at the entrance. He's not only checking IDs, he's running Boolean logic. Now, we can take a look at the different examples in this code. In the first line, we see the AND operator. With that code, you must be 18 or older and have a valid ID. Both conditions have to be true in order for you to get inside. If either fails, you're too young or you have no ID, you're out of luck. In the second line with a different example, we see the OR operator. It's something that's more lenient. If your grade is either an A or a B, you pass the check. You only need one of the conditions to be true. And in the third line, we see the NOT operator. It flips the logic. So this condition only runs if you're not logged in. It would be something equivalent to saying, if you don't already have a wristband, go get one. Boolean expressions are what make branches meaningful. They allow code to check multiple things at once, combine conditions, and adjust them when needed. And then here is just a quick reference table for common Boolean operators that you will use all the time. You can think of it like a toolkit for decision making. The equals is the equals operator. You would use this to check if two values are the same. For example, in a video game, you could say if score equals 100, it checks if your score is exactly 100. The next one is the not equal operator. It does the opposite. It returns true if the values are different. Greater than obviously means greater than, and it's perfect for comparing numbers. It's important to note you can also use different operators like less than, greater than or equal to, less than or equal to in a similar fashion. Now we look at logical operators. In the fourth row, we see and, the and operator. Both sides of the condition must be true, as seen in the previous slide. It means both conditions must be met. In the next line, we see the or operator, where only one condition needs to be met, and finally the third line, the not operator. It flips true to false and vice versa. Now, we can look at a familiar scenario, something we all experience, a login screen. Here is where we can look at nested if statements. The logic isn't just one decision here, it's a decision inside of a decision. So in the code here, first, we check whether or not the user is logged in. If not, we immediately send, please log in. However, if they are logged in, then we go another step and ask, are they an admin? If yes, they get the admin greeting, and if not, they're welcomed as a regular user. This is called nesting, where one if condition wraps around another. It's really useful when you need to evaluate or validate a sequence of checks in a specific order. Here are some really common mistakes. Here are three that I myself have run into. Mistake one would be omitting the braces. So at first glance, it seems like both lines are part of the if statement, but they're not. Only the first line is controlled by the if. The second line will always run. So it's important that you use curly braces even when there's only one statement. Mistake two is using one equal sign instead of two. A single equal sign is an assignment, it's not a comparison. So this code sets x to 5 and the condition evaluates as true, even if that's not what you meant to do. The third mistake is unreachable code, where if a condition is always true or false, in this case, if true, then the other branch will never execute. That's called unreachable code, and the compiler might warn you about it depending on what you're running. Unreachable code clutters up the program and makes it hard to find logic errors. You can think of each of these mistakes like taking a wrong turn at a fork in the road. The path still runs and it still functions, but it doesn't take you where you want to go. And then for a real world example, we look at an ATM. Imagine you walk up to the machine and insert your card. The machine then has to verify two things. It has to verify that your card is inserted, and it has to verify that you entered the correct PIN. This is where nested if statements become really helpful. Here, we assume the card has been inserted and that the correct PIN is 1234. The first check is whether the card is even in the machine. If it is, it then asks for the PIN. Then, it goes deeper. If the entered PIN matches the correct one, the machine grants access. If not, it responds and lets the user know that the PIN is incorrect. And finally, if the card wasn't inserted in the first place, this example is a great demonstration of structured branching. Every possible input is handled clearly, and each level of logic is dependent on the one above it. So, in summary, branching in C++ is what makes your code smart. It allows your program to react to input, make choices, and take different paths depending on the situation. If-else gives you basic two-path logic, a simple yes or no. Else-if lets you build more complex decisions with multiple conditions. Switch case is your go-to for clean, readable comparison against constants, and Boolean logic lets you combine or flip conditions for more advanced control. Nested branching also enables your code to make decisions within decisions. But branching is more than syntax, it's how the program thinks. Just like the person in this image has to make a decision, your program evaluates the situation and decides what to do next, based on logic, data, or conditions you've written. Whether you're writing a vending machine menu, a login portal, or a game dialogue, branching is the tool that allows your code to maintain intelligence.